Before we go into the specifics of math assessment measures, it's important for us to just review the critical skills for math achievement, and then to create that understanding of then how those skills are linked to the measures we use. Like the National Reading Panel, the National Math Panel was charged to review all of the available research on math assessment and instruction and to make recommendations. For individuals, we know that math performance correlates with access to and graduation from college and income, so it's important for us to have a clear understanding about how do we prepare students to be successful in math, leading to these longer-term, very socially significant outcomes. Setting the stage for the work of the National Math Panel was the current status of math achievement in the U.S., which was less than ideal. So national report card data show positive trends at 4th and 8th grade, but only 32% of our students are at or above proficient level in 8th grade, and only 23% are efficient in 12th grade. And we see a sharp decline in math achievement happening right as students begin coursework in algebra. So if you take a look at the National Math Panel's executive report, which is optional reading for this week, you'll see that much of it is framed around this idea of preparing students for algebra. So leading to the question, why is algebra so important? Algebra is a gateway to later achievement. We know completion of Algebra 2 significantly correlates with success in college and income, and students who complete Algebra 2 are more than twice as likely to graduate college. Also, it seems that the completion of Algebra 2 kind of wipes away some of the differences in graduation rates we see between minority students versus general student populations, with the differences being half as large for students as compared to those who do not complete Algebra 2. So leading up to having students being successful in algebra, the National Math Panel identified 3 critical areas for skill development in students and also benchmarks, so time frames for when we should see proficiency. So the first critical foundation skill is fluency with whole numbers. And the panel summarized that by the end of 3rd grade, students need to be proficient with addition and subtraction of whole numbers, and by the end of 5th grade, they need to be proficient with multiplication and division of whole numbers. Students who are fluent, so they can respond accurately and quickly to subtraction, addition, multiplication, division problems, that makes everything else in math easier. So the parallel is when we discussed reading, students who can read fluently, they have those basic skills in phonics and they can read automatically, then that helps them comprehend. So they're not devoting effort to decoding individual words. The same in math. If students have those basic skills with computation, then they can do word problems, they can move on to algebra without thinking through, if you think about it, without counting on their fingers or, coming up creative ways, that they automatically know the answers to those basic whole number problems. The next critical skill identified by the panel is fluency with fractions, and they set up benchmarks for how skills should develop and be demonstrated with fluency with fractions from 4th grade all the way to the end of 7th grade. So it starts with being able to identify and represent fractions and decimals and compare them, moving on to the multiplication and division of fractions and decimals, and also being able to do calculations involving positive and negative integers. So by the end of 7th grade, students need to be proficient with all the operations involving positive and negative integers, and be also able to solve problems involving percent, ratio, and rate, and extend this work to proportionality, again leading up to performance in algebra. The third critical skills were fluency with geometry and measurement, and these skills involving by the end of 5th grade, students need to be able to solve problems using perimeter and area. By the end of 6th grade, they need to be able to analyze 2-dimensional and 3-dimensional shapes, and by the end of 7th grade, students need to be familiar with the relationship between similar triangles and the concept of slope of a line. Largely based off of the findings from the National Math Panel, the Institute of Education Sciences developed a practice guide to support implementation of the suggestions for math instruction. And it provides this in the framework of a tiered approach, a response to intervention tiered approach, and includes 8 recommendations with supporting evidence. And in this presentation, I just wanted to highlight 2 of the recommendations that are linked to the math assessment measures we're going to talk about this week. So our first recommendation calls for the universal screening of all students to identify those who are at risk, so then you can provide interventions for those students. And for the rest of this week, we're going to look at math CBM measures, and as you'll see, they're completely appropriate and efficient, reliable, valid indicators of math performance, and those can be administered to all students for this universal screening in an efficient manner to identify those students who will need extra support. The recommendation 7 calls for the ongoing progress monitoring of students who receive intervention or may be at risk. And again, our CBM measures are appropriate for this. They have good technical adequacy, and they can be efficiently administered to get data on how students are responding to the interventions we put in place.